Now, when you see these vast polar regions, all that white, all that ice, you might think that's all there is. But there's a lot down there. The trick is figuring out what is down there.
Absolutely. Not only are there things down there, but there's things in the ice as well. You never want to be fooled by a frozen landscape. These are very complex landscapes. In some cases in the Antarctic, you'll have a series of submerged or under ice lakes, if you will. They stay liquid, but you've got to go through the ice to get to them, sometimes meters at a time. In fact, in one case, Lake Vostok is 2.5 miles through ice until you reach the lake surface itself.
Huge challenge to get down there.
Big challenge to get down there and study it. And also you have to be very sensitive to the fact that this lake has been isolated for many, many years. As soon as you punch a hole down there and start messing around to study it, you've altered that lake habitat. So what you want to do is be very careful about your technique to get there and very careful about how you take samples from the lake water itself.
Interesting.
And that's exactly what this next activity is about. We're going to model Lake Vostok and pull some samples.
Good, let's go.
All right. Okay, what we've got here is 6 of us, 7 counting myself. We'll divide up into teams of 2. This is a rather complex activity. It's a very good one to do with older students in the classroom environment or kids at home if you've got more time to work with them. It may take a couple of class periods to work your way through. Let me first tell you a little bit about the materials that are out here and the way the activity is set up. As I mentioned in talking with Richard, grab the book here, what we're going to do is we're going to create a model Lake Vostok, if you will. We're going to do this in these plastic containers here. Now, normally in a lake environment, of course, there aren't colored layers per se, but the water density and the amount of minerals dissolved in that water and the kind of life living in those layers does change layer by layer. We're going to create a model using different colored liquids, as you can see on the table over here. We're going to stack them up carefully in our jar. We're going to hide that jar with black paper, and then we're going to do a mix and match and trade jars. And then our challenge as individual teams will be to sample the layers in that model Lake Vostok with a sampling device as sophisticated as a straw and see if we can discern through graphing what the actual layer system is in that container. Okay, go to work. We've added just basic food coloring in here to color the water so we can discern the layers. And I suggest that you carefully put that material down at each layer by putting it against the side of the container itself. The advantage of that is you don't just go and mix it all up every time you squirt it in there. Little trick with a baster, when you use the suction, you squeeze that bulb first and put it down in the liquid and then use it to suck the liquid up. If you keep it directly straight up and down, that suction should hold a little bit better. As soon as you turn a baster and air gets in there, it just flows right out. Another way to handle the sorting out of these liquids on your classroom tables or counters is to actually separate them in the room by some distance. You could have the most dense liquid in one corner and then sort of go in order around the room on the back counter perhaps. Because no sooner do you begin than people start grabbing the containers and moving them around, just as we are doing here. Students will do it as well. But it is important just to save time to add them from most dense to least dense. Otherwise, it'll just take a day or so to settle back out again. You want to work that ice sheet right down to the surface of your first liquid. It might be easier to put that ice sheet on before you put the black paper on. We need to calibrate our sampling device. So we take the clear straw, and you want to mark 2-centimeter increments with the little black pen on your straw so that you've got an actual quantitative measure when you take your samples. Once you've made those markings, you can seal this in clear tape. Do you think it's easiest to just go all the way to the bottom first and sample all the way through? Or what's an alternative?
You could start at the top and just go a little bit.
Absolutely. Just a little bit at a time, because what that does is it allows you a little less mixing of those layers as you go, and you'll get a better sort of reading of that. You could, in fact, go all the way to the bottom with one sample and come up again. One of the risks in that, though, is you won't get much of a sense of the across-the-board regular mixing of each of those layers. You get a one sample only, but you won't get a regular mixing of those layers. So I would suggest some incremental layering. As you can see, we have our 3 lakes here ready to go. In order to make this fair, I'm going to have you all turn your backs now.
Okay.
I will then mix up the various lakes. They'll never know which lake is which. And okay, you can turn back around. This will be yours. This will be yours. And this will be yours. And why don't you just position yourselves around the tables here and use a piece of this graph paper if you like and start recording the samples as you extract them from the lake. Deborah mentioned to you, obviously, that if you submerge the straw in the liquid, tap the end with your finger and pull it up, you'll get that liquid trapped in the straw. Another very interesting thing about it is you can reverse that process. Start off with it tapped, put it straight into the liquid, and it won't bring liquid up into the straw until you release your finger. So it's another way for you to sort of make your way through certain layers in advance of sampling. So let's take a look at Stacy and Becky's first. If I hand you that sheet, if you could just keep it held up so everyone can see as well as the folks at home. So there's your 1 centimeter dark on the bottom. And then you come up here and you've got about 1 1/3 centimeter. Very good. And then the middle layer here?
Yeah, 2 centimeters of the clear.
2 centimeters of the clear. What would you say? Pretty darn close. And the last layer?
1 1/2.
1 1/2. Yeah, it might depend on where that ice sheet on top is. This looks like about a 1 here, but it might have gotten scooted down a little bit more. Okay, give them a hand. That was nice of them.